Je to tam, tak můžeš.
Okay, so welcome everyone. Today I will be introducing you to S-Pipes modules and their usage. This presentation is follow-up on the S-Pipes presentation given in November by Miro. In case that somebody doesn't know S-Pipes, it is a tool to manage semantic pipelines defined in RDF, and it is inspired by Sparkle motion language. And before we dive into specific modules and how to use them, let's first define what a module is. It is a building block of a pipeline that performs a specific task. And these modules are stateless transformations of input data and can be used in pipelines. They are usually implemented in Java, but executions of modules are parameterized within RDF. And each module has to have a unique type URI, and it consists of execution context. It is important to mention that S-Pipes uses Jena framework for RDF data manipulation. Each S-Pipes module can have any number of input and output constraints. It is the validation constraints in Sparkle query. Currently, S-Pipes support two types of queries, ask and select, and ask returns true if validation constraint is violated, and select returns non-empty binding if validation constraint is violated. And in the picture, we can see that it is validating that every person has first name and last name. It is the first picture on the right, and that each person is at least 18 years old. It is the down below. While S-Pipes comes with many useful modules, sometimes you may need to create custom modules to fit your specific needs. Creating a custom module is simple as it is developed using Java, and it is automatically generated. When we create new module, we have to include information about a new module in other repository in S-Pipes modules. It is kind of inconvenient, but this will be deleted soon. We have also module archetype, which is a Maven archetype for generating a clean template for a new module. I will show this in a demo in the end. And we have the other Maven plugin, which is used for processing existing modules, and it takes care of updating RDF ontologies. Okay, the most used module is apply construct, which is responsible for applying Sparkle construct queries to RDF data. The module takes in one or more construct queries as an input, along with the other parameters like whether to replace existing data and how many iterations to run queries for, and so on. The output is constructed RDF graph. It is important to mention. The advantage is that you can build more constructs and combine them and connect together. We can see in the picture how apply construct is used within pipeline. You specify construct body and where clause. Next, we have bind by select module, which runs a select query, and it binds all result variables of the first matching result set. The input RDF is simply passed to the module. For example, if you run the select on the screen, it will bind the name and age as output variables. Then we have text analysis module, which is in progress now, and it takes an input RDF with letters, and this module annotates it with analysis service, and the output is annotated letters pointing to the original letters. Then we have the other one, extract term occurrences, and as the name suggests, it extracts term occurrences from annotated literals of input RDF, and these literals are annotated by RDFA, which is RDF but in HTML attributes, and it is annotated using terminology to mark occurrences of terms and rate them with score. The combination of these two modules allows us to annotate literals and then get the term occurrences. To deploy data to a remote repository, we can use RDF4j module, which deploys data to RDF4j server, where you have to specify some parameters like credentials or context IRI. And the last one is RDF4j RDF2CSV module, which is responsible for converting the input RDF data into CSV format, and it saves to this CSV file. The table is reconstructed from column and row resources, which is defined in table schema, and this table schema is necessary to be present in the input for this module. The tabular module is a module in SPipes that enables the conversion of CSV or TSV data into RDF data. The implementation loosely follows the W3C recommendation, and CSV is comma-separated values. It is a popular data format used to store tabular data in a plain text. Most people know this from Excel. However, RDF is more flexible and powerful framework to represent the data. And okay, tabular module also creates annotated table, which adds some additional metadata, which are columns, rows, and schema. And the schema is definition of tabular format that may be common for multiple tables. And this schema is an object that has information about schema, which describes the structure of table, and there are rows, columns, and so on. And this module can also be used to process HTML tables and transform them to RDF. And it works the way that it converts the HTML table to TSV and then process it like usual TSV. Okay, now comes the demo time. So I will show you first how generation new module works. So we have this archetype module and this script where we specify some artifact ID and name. So I will leave test own article and module name will be foobar, and I will just run this script to generate new module. Okay. And we can see that here is new module, which has POM, and it has some this expected module, which is annotated abstract module. Yes, and this is how the creating works. It is kind of fast, but now it is needed to include it into SPipes modules, like I said earlier.
Maciej, can you please zoom it a little bit so it will be better visible?
Yes, sorry. Is it better?
Yeah, thanks.
Okay, so okay, so we have this new created foobar module, which extends annotated abstract module, and it has some resources, like and it is type of ontology and some info about a new generated module. Okay, let's move on the second demo. I have some pretty simple input CSV, which contains some people with first names and last names, age and gender. And the first thing I want to show you is how do we convert it to tabular module. And the output is on the right here. And we can see that we have some triples and some table which has rows, multiple rows. And if you go down, we can see that there is also table schema, like I mentioned. So from this, we can reconstruct the original CSV, and we can see that it has columns. For example, this blank node B1, it represents the first column, and it is first name. So we can see that it matches. And we can have a look at some row. For example, this row. And we will look at a triple, and it says the row 3 has these values. It is Jane Doe, 23 years old, and it is female. And this is how the table looks like. And now I will show a pretty simple apply construct, which gets the average age per last name. This is just a pretty simple construct where I create last name IRI and select the average age. So we can see the output is the last name and the average age. This is just pretty simple, just to show how it can work. Yeah, so that's it from demo. Thanks for the attention and for listening. And if you have any questions, don't hesitate to ask.
Thank you, Matej, very much for the presentation. So, are there any questions from the audience?
Maybe can you say something about this tabular model? What kind of parameters it has? Like what can you configure to run the module? Like,
Okay. We can take a look. Okay, so these are the parameters we can specify. It is delimiter, and it means how we parse the data, how we set the delimiter. So in the CSV, the delimiter is comma. We have quote character, which is double quote in CSV standard, and also we have except invalid quoting. It is for the case that, for example, there are only one of quote characters and not pair. We have data prefix. Also, we can skip the header if we don't want to include it. And also we can process HTML files like I mentioned before.
okay, thanks.
Okay.
So this is all generated by the script, all these constants?
Yes, you specify this in the script, yes.
Oh, okay, so you have to specify it in the script.
Yes, you have to specify.
Oh. And is there, so I misunderstood maybe, so the script is not provided by the archetype. You have to write the script yourself, or is there some sort of skeleton that you can use?
You have to write the script yourself.
Okay. Okay, thanks.
Okay, I'm not 100% sure that we are clear here. Just rather, I will say it as well. So this is a model that can be used in script. This tabular model, you can convert any CSV into RDF, and those are the parameters of this model. So within the script, you use this concrete model with some parameters. So for example, with delimiter, which is comma, with quote character, which will be apostrophes, and so on. And Matej was also showing that you can generate that you can generate RDF from Java. So if Matej, if you could show one model and how it looks like in RDF. So for example, apply construct.
Apply construct, okay.
And can you show the RDF definition of this? So here is, for example, iteration count parameter, parse text parameter, is replaced parameter. And could you show it in RDF, how it looks? So every such a model has also its counterpart in RDF. But I didn't mean this is usage of this model, but I thought you would show the definition of the model. And in the definition of the model, you can see each parameter and documentation to it, or some constraints how to use it. Yes. And I just wanted to say that we can generate from annotations in Java, we can generate those constraints as well. So for example, tabular model, yes, this is tabular model, and here is spin used to define this model. So this is only thing that you can generate from Java, but not script, but the definition of the model and their constraints. This can be generated from annotations params, which you can put on any field, and that should do it. So that's all I wanted to say. I hope I clarified something, maybe not. So that's it.
Yeah, probably not, because I meant the shell script.
You meant the shell script
That's the script I was talking about.
This script just generates a new template, but for the module in Java.
Yeah, I get it. But you have to write this script yourself. It's not provided with the archetype.
Yeah.
Yeah.
You can call the archetype itself with parameters. So this script is not doing much. It just calls the archetype with those parameters. And I believe this script is included in the repository. So you could either edit it and run it, or you just call the archetypes itself.
Okay, so any other questions?
Doesn't look so. So thank you very much for your presentation. I'll stop any like to remain.